Hi everyone. In today's lesson, we're going to talk about how to find limits algebraically when using factoring. So as we did yesterday, we're always going to try direct substitution first. And if your answer is a real number, then that's your answer. But today, we're going to have scenarios where you don't get a real number. So we're going to get something that's called an indeterminate form. So if your answer is 0 over 0, it's called an indeterminate form. That means there must be a hole in the graph at that x value. And the only way out of it is to use factoring. We're going to use conjugates and common denominators for another day. So for today, we're going to get scenarios where we try direct substitution, but now we're getting 0 over 0. Visually, that means there's a hole in the graph, and the way that we can get out of the hole is by factoring. So as usual, I'm going to have a visual representation. So here's the graph right here of this function, this fractional function. It's called a rational function. So you can see that there's a hole here at x equals -4. So I want to find the y value as x approaches -4. But if you were to try this without the graph, you would say, okay, I learned direct substitution. So your first step would be direct substitution, and that's completely fine. So you would plug in -4 for every time you see an x. Now, if you typed this into your calculator without the separation of the numerator and denominator, you would probably get an error. So I'm going to strongly advise that you plug them in separately. So go ahead, pause the video, plug the top in, plug the bottom in separately, and get two answers, and then hit resume when you're ready. Okay, so you should have gotten 0 over 0. And that's perfectly fine. That means that there is a hole in the graph at x equals -4. So the way that we can avoid this hole is by factoring the equation. So we're going to factor the numerator and factor the denominator. Well, it looks as though the factoring for the numerator is add multiply. So what numbers multiply to 4 that add to 5? Only 1 and 4. And it looks like the denominator is just x plus 4, so we actually can't factor that. Now what you should notice is going to happen is you're going to have something that's in common that you can cross off. So because we cross off the x plus 4, now we can treat the problem as if we had just x plus 1. So if I want to take the limit now of x plus 1, I'm going to use direct substitution. So I'm going to directly substitute my -4. So -4 plus 1 gives me -3, which is my limit. So step 1 was direct substitution. Step 2 was to factor and simplify. And step 3 was to substitute back in. So we're substituting that -4 back into my reduced equation for a limit of -3. Now let's just check with the graph. Does the limit from the left equal the limit from the right? Is it the y value of -3? Absolutely. So I'd like you guys now to look at example number 2 down here, and I'd like you to try it on your own and then hit resume when you're ready for the answer. All right, this is what I got. So the first thing I did was I tried direct substitution, which when I plugged in 4, I got 0 over 0, which makes sense. Here's my graph. At 4, I have a hole. I factored the denominator and canceled out. Remember, if there's nothing left on top, you need a 1. And I then plugged my value of 4 back in here. So now I have 1 over 4 minus 2, which is 1/2. And we can check with the graph, the limit from the left and the limit from the right approach the same y value, which here looks less than 1, which could be 1/2. So that's it for 2 direct substitution problems. Let's try a couple more. All right, so now I have no picture, and I expect that you're able to answer these limit questions without the graph. So what do we always try first? We're always going to try direct substitution. If that doesn't work, and we get 0 over 0, then we factor and simplify and replug back in. So I'd actually like you to try these next couple of examples by yourself and then hit resume when you're ready for your answers. All right, this is what I got. So for number 5, we tried direct substitution first. That gives me 0 over 0. Then I realize I have to do some factoring. And you should be recognizing that this x to the third minus 125 is actually SOAP, so sum and difference of cubes. Remember, the formula for that is a squared, ab, and b squared. So my a in this case was x, and my b was 5, because x to the third is x to the third, and 5 to the third is 125. So in my formula, x squared is a squared, 5x is ab, and b squared is 25. And then I did same opposite, always positive. So same sign as the original goes in the front, opposite, always positive. All right. And then I crossed off the x minus 5s and I plugged it back in. So plugging it back in, I got 75. All right, that's one. The second one here, I tried direct substitution and I got again 0 over 0. Then I did some factoring. So what you should notice is that there is a trinomial here with a leading coefficient greater than 1. So you can do AC, where you multiply the first and the last, and you get negative 24x squared. You want the factors of negative 24 that are going to add to 5. So that should have been negative 8x plus 3x. Then I bring down my minus 12 and my 2x squared, and I factor by grouping. The GCF out of the first two is 2x, and I'm left with x minus 4. The GCF of the second two is 3, and I'm left with x minus 4. Then my x minus 4 is my last GCF, and I'm left with the outsides, which are 2x plus 3. Now, you can do guess and test. That's kind of how I got this real fast, but that was a quick little review of AC. The x minus 4's cancel, and then I resubstitute back into this equation my 4. So 4 times 2 is 8, plus 3 gives you your 11. And here's the answer to the last one. The factoring is actually what's going to be the hardest part here. So you do your direct substitution, you get your 0 over 0. But when you factor, because of this leading coefficient being negative, my first instinct is actually to take out a GCF of negative 1 and then do add multiply. So what adds to negative 1? That multiplies to negative 6, and with this negative 1 on the outside. So by doing that, you can cancel out the x plus 2's, and you're left with this equation. Not too pretty, but it's still as simplified as it's going to get. And then for x, I plug in negative 2 here, and I got negative 5/6. All right, that's it for today. If you have any questions, now is a good time to jot them down, and we'll see you in class tomorrow. Have a good night.